What's up, guys? Now let's discuss important data representation considerations when developing an API. So there are a lot of different formats that our requests can be in, right? You can use text or binary. We have JSON, XML. Let's discuss the different trade-offs in this section. So let's talk about data representation and efficient communication in APIs, right? So we want to choose the best data representation for our current API that we're building, right? So this is an essential part of the request response communication. Is the data format, right? So an essential part of our request response is our data format, and this can be the difference between effective versus inept design, right? And choice in API design. So this is definitely a choice that we make in API design, and the data format for both the client and the server are important consideration. And, changing and updating the data format over time is inevitable, right? So if you're on a team and you have you have an application that does certain things, you're at times gonna, update your the request you're looking for, right? You're gonna update your fields and you're gonna add new things that you want, or you're gonna update your response, right? And so changes server side might also need to be made on the client side, right? So if you add something that's really important to your server, what your server is expecting in terms of a request, then maybe you need to do some versioning and switch to version 2.0, right, of your endpoint, right? So that keeps backwards compatibility, right? But with web apps, simply refreshing can get the client onto a new version, right? But if you have a downloaded app, that needs updating. Like, it needs time to update, re-download the application and stuff. And so data representation and versioning are obviously important considerations. And we'll discuss why data representations and formats matter and the considerations when choosing one. So let's discuss those considerations, right? It's not as simple as let's, just choose the simplest form so our client can understand it, right? We obviously want something that has low latency. It's, a common concern, and data structures that facilitate fast network transfer, that's definitely a consideration, right? And you also want something that has fast processing, right? So human readable formats are good where frequent debugging is required and you have developers that need to look at these requests and responses. But this is not like a machine-friendly representation such as binary, right? And so the time required to process is important when choosing a data representation. So, if you have a lot of data and you also, have devices with low processing power, there's different scenarios where, knowing these things matter, right? So, we also have to consider multiple format support, right? So as influenced by our following question, how many formats will our API support? What schema will we use to encode and decode these formats? How will we preserve data while it's converted from one form to another, right? And many languages support encoding and decoding and can be inefficient as a result of processing time and the size of the transformed data, right? So, yeah, you don't want to constantly be converting between different formats. Definitely adds up on your processing time. And another consideration is restricted data format. So format is subject to the business goals, and depending on the business, stick to the specific data formats there to reduce costs and satisfy the business logic, right? So if everyone in a company is using JSON, it's best to just use JSON for your application, since, it satisfies our business logic, and, it'll reduce costs in that sense. So Google has many applications such as Maps, Search, YouTube, etc., that are interconnected, and it would be, very challenging, a data format, right? Because that would require a lot of updates. And so, data format can affect how data is stored in the database, right? So this may cause unnecessary transformation and processing power, right? So if you have if you have to transform your data every time you get a request into appropriate, data structure for your database to store, changing your data format could be a consideration, right? And so that you also have, custom data formats, right? And this can invent, you can invent custom data encoding formats if you really need it. And it can come with a cost that the data can only be understood by their applications and not interface with, other third parties, right? And, you also want to be flexible. So newer versions of APIs may change in the data format, right? So with software upgrades, we have to roll back changes due to unexpected bugs or security reasons. At least 2 versions of the data must coexist for the server in order to present any inconvenience. There needs to be some flexibility when changing data formats in use. So there needs to be forward compatibility, adding new attributes to request response data so existing code can be read and data written by a new code base. And you also need to have backwards compatibility, the ability of a data format to withstand changes in the existing attributes to the request response data, so new code can be read and understood, and understand data written by an older version. And full compatible, a data format that is backwards and forwards compatible with the changes made to the request response data, right? So how bad would things get if I pick an inappropriate data representation? So this can cause serious damage to the API, and converting from one format to another consumes computational resources and adds latency, and correctness issues can arise. Conversion of the code needs to be really perfected, right? So the best data format for a design problem is a trade-off between the factors mentioned before. A good format is a choice as it supports human readability, so it's easy to read and debug, low latency, fast to transmit over the wire. It's standardized, it follows a well-defined pattern in the industry, machine-friendly, there's less time to be processed by the machines, interoperable, it's easy to serialize and deserialize data into different formats. It's also flexible, it's easy to introduce and manage changes, right? And we can divide the different data representations into these 2 broad categories, which are textual data formats like JSON or XML, and then you also have binary, which are, read well by computers, not by humans, right? And so let's do a quick quiz. So low latency, we just need to match these to the appropriate ending, right? So low latency can be achieved by, so the first choice is requires less processing time and can be automatically read by computing devices. That sounds more like, less processing time, something like that, or a machine-friendly format, right? That sounds like this. Easy to add changes and manage updates when using first-party applications. Doesn't sound like latency. Utilize compact data structure to speed up network transmission. It sounds like this, right? Because we want to have the right data structure for fast transmission. so that'll reduce latency. So the term interoperability refers to one choice here, the ability of different systems to easily store and retrieve data during transmission, right? So it definitely sounds like interoperability because, many devices can encrypt and decrypt very easily, and, this makes it easy to cache and things like that. And so that leaves us the advantages of a custom data format are it's easy to add changes and manage updates when using first-party applications, right? So if you have a custom data format, it makes it more difficult to interface with third-party applications, but first-party applications, all the applications are using this custom data format you have, then it's a good idea, right? So hopefully you learned something. Thanks so much for watching.